Hello, welcome to this video. In this video, we are going to be going over the parameters surrounding the two final exams here in Chem 106. So without further ado, let's get into each of those. And we're going to start actually with the practical. So in the practical exam, the information that is important to you, and this information is being sent to you separately in an email, it's also on lab archives. What we are telling you is this: the practical exam is 50 points in total. 30 of those points are for the group notebook that you will submit with your partner. 20 of those points will be for identifying the ions correctly that are there. And how it works is this: you and your partner will be together. You will get a sample of about 1 milliliter of an unknown substance that is going to have several of the ions that we've studied. Your job as a pair is, over the course of 2 lab periods, to characterize that unknown. And you'll be using the procedures that we have used throughout the semester for the groups 1, 2, and 3 ions. So the difference is, instead of taking the group 1, separating off those chlorides, and then throwing out the rest, this time you'll take the chlorides, separate them out, and then that substance will become the unknown that you use for the group 2 analysis. You complete the first couple of steps in the group 2 analysis, get all of the sulfides and hydroxides and whatever characterized off, and then you'll split that off, and that'll become the group 3 analysis. So instead of having separate samples for each of those unknowns, what you're going to have is one sample that is going to flow from group 1 to group 2 to group 3. Now, here are some parameters. There are multiple unknowns, but each unknown will either have 6 ions in it or it will have 7 ions in it. Very, very narrow range in here. Another important note is that mercury, we are testing for broadly, meaning we're going to take an assumption as your professors that some of the mercury is going to transform in solution. So we can't be too certain that if we put mercury 1 in there, that some of it wouldn't turn into mercury 2 over time. So what we're going to do is we are broadly going to test for mercury. You will test for mercury 1 and mercury 2, but you'll be only asked the question, is mercury present in the sample? So you don't actually need to differentiate between the two. As far as how those ions will be distributed, no more than 3 ions can come from a single group. So in that discussion, that means that mercury and lead are actually crossovers because they're both of the group 1 and the group 2 analysis. And so we're going to treat them as such, meaning if you find lead, it would count as a group 1 and a group 2 ion. If you find mercury, it will count as a group 1 and a group 2 ion. And there can be no more than 3 of those ions in any sample. There will be representatives of all 3 of the cation groups, though. So it's not like we're going to get to group 3 and there's going to be nothing left over that you're going to be able to look at. You have to complete all the work by the end of the second day. If we do need a third day, it'll come out of the written final day, as we've discussed before. How this is going to be formatted, how this is going to look and feel as far as you are concerned. This is very much going to look like a group quiz. So you won't necessarily have the same unknowns as everybody else, but you will have the ability to look at each other and say, okay, does this look like a positive test? Does this look like a negative test? You can talk to each other. You can certainly talk between classes because there will be overlap among sections. But my involvement in this, because it is a group exam, because it is a final exam, will be very, very minimal. I really can't direct you. I really can't push you in any direction or interpret your results for you. I'm going to try to keep out of it as much as I can because I don't want to influence your analysis in any direction, one way or the other. Now, even though this is a group project, each student is going to have responsibilities. Each student's going to have to record the procedure, record their observations, analysis, net ionic equations, just like before. The only difference is that instead of putting them, into your own notebook, you'll be putting them into a combined notebook that you'll turn in as a group at the end of the analysis. As far as submission is concerned, the submission and of the identity of those ions, you're going to take a Blackboard quiz like you have for every other one. It's going to be in that lab quizzes folder in Blackboard. It'll be due not by 3 o'clock, but rather by 11:59 p.m. on the Friday before finals week, which is April 29. Just again, make sure you choose the correct form, just like with all the other ones. If you choose the wrong form, it's going to be looking for different answers than what you produce. Same thing with the notebooks. The notebooks need to be submitted in lab archives by 11:59 on the 29th as well. Obviously, if you can turn it in sooner, that's better. I'll be able to grade those out and give you a much better picture of where you are in the class with an earlier submission. As far as the notebook is concerned, it very similar to what you did for the individual analyses. Make sure that you have proper procedures. Make sure that you have observations and analysis. Make sure that you've got the equations in there and that they're all formatted properly. My suggestion to you, make a Google Doc and work on the Google Doc during class together. And then all you have to do as far as the notebook is concerned is when you're finished with it, attach that Google Doc to the notebook page, submit it as a pair. It's already done. You don't need to separate. So if you go into lab archives, I have places here for your group 1, group 2, group 3 analysis and conclusions. You don't have to do that. If you put it all in a single document, just attach the document to the top here, we're fine. Just make sure that it has the group 1 table, the group 2 table, the group 3 table, and a conclusion statement written on it somewhere so that I can find each of those things. One important note though, if you, for some reason, you do not do part of the analysis, maybe because you already eliminated all of the options, you don't have to include those procedures. So the example I give here is if you're doing the group 3 analysis and you determine that the first 3 ions are all present, you don't need to do the analysis of the back half of group 3. You can stop right there and not do the aluminum, chromium, and zinc. That would save you some time if you're certain that that's what happened. My personal suggestion would be that you do all of it. And that way, if there are multiple let's say that you find that there are 8 ions present or 9 ions present, then at the very least, you can kind of winnow it down in terms of, okay, that one was really, really positive, and this one's kind of vaguely positive. Maybe you can start trying to identify what your false positives were. The grade on the notebook will be determined using this rubric. This rubric has been given to you in Lab Archives. It has also been given to you in the announcement that came with this video in Blackboard and in your email. So check it out there as well. It's very, very similar to the notebook rubrics that you've been using all semester long. So that is the practical final exam. Let's turn our attention then to the written final exam. And for the written final exam, relatively simple. If you remember the final exam in Chem 105, it is in a similar format to that. The only real difference between the two exams is kind of the format itself. Are not going to be any procedure questions. There's not going to be any kinds of questions about observations. It's going to be more on the calculations, because these 8 experiments, these actually, I guess that's only 7 experiments. These 7 experiments are very calculation heavy. So there are 7 calculations, or 7 experiments rather, that we need to look into. The first being the heat of formation using Hess's law. The second being the thermodynamics of borax. You've got a kinetics lab in here, the kinetics of dye. You've got an equilibrium one here with Le Chatelier. You've got an acid-base one here with the KAKB and hydrolysis lab. You've got the titration curves from the advanced aqueous equilibria, and you've got electrochemistry here, the last unit. So you've got all of the pieces and parts there. This is a good kind of general representation. So it kind of covers everything. Now, if you want to look at, what should I study? What should I do? Focus really hard on those calculations in these labs. Make sure that you know how to do them. Make sure you know the concept in general that goes into it, because that's really going to be what's helpful to you. So, for these labs here, they're all thermodynamic based. Do you know how to use Hess's law? Do you know how to do calorimetry calculations? Because calorimetry was a big part of both of them. So, those kinds of things. Can you get into that kind of specifics? Do you know the relationships between Gibbs free energy and enthalpy and entropy? For the kinetics of dye, that one focused primarily on integrated rate law. So do you know how to interpret an integrated rate law? Do you know how to interpret the graphs? Can you do something with an Arrhenius equation? That kind of thing. General equilibrium. Can you do Le Chatelier's principle? Do you understand how equilibria are affected by different stressors? Acid base. Can you do Ka and Kb calculations? Can you correctly identify whether a salt is going to be acidic, basic, or neutral? Titration curves. Do you understand how to interpret a titration curve? Can you do the calculations in the buffer region? Can you do buffer calculations? Can you determine what the pH at the equivalence point should be? And then electrochemistry. Can you calculate E-cell? Can you calculate reduction potentials based off of data? Do you know what electrolysis is? Can you predict electrolytic products based upon reduction potentials and oxidation potentials? Now, to help you with this, I have given you some material. So one thing I've given you is this practice test. This is a practice test that we wrote last year, and it gives you just some general information, some types of questions that you can be asked. that go along with each of these sections. Now, in addition to those, if you go here into Blackboard to the area marked useful resources, this solubility rules chart and data table have been there the whole time. These here at the bottom have been as well, but they haven't been useful to us until right now. So in here, you'll find the information sheet that I just showed you. You'll also find a key to that practice exam, so you can download that. And this is my version of all of the correct answers to it. So these are what I wrote in myself. And then if you're looking for extra practice, not all of it's terribly relevant in information. This is a 3-year-old document now, but you could look at this and see, okay, hey, we've got some of the same things. Hess's law, kinetics of dye, Le Chatelier, acid salt and buffers, titration curves, borax, electrochemistry. Well, that sounds familiar. Well, here's a practice exam that I gave 3 years ago, and you'll see there are some common threads in here, no doubt. You know, compare them side by side. Yeah, some of these questions are identical, but some are different. Here's a more specific titration and Ka question. Here is a graphing kind of question. Oh, actually, no, this is a method of initial rates, which would not be on the exam because we aren't featuring that one. Here's a more specific Le Chatelier problem. Here is another, it's the same acid-base salt hydrolysis question. 9 and 10 are identical to those. Here's a different question here on the pH of a buffer solution. So there are some things that are different. There are a lot of things that are the same. The reason for that second document, the one was just to update it a little bit. That's why there's a lot of common threads there. But you'll see that I've given you the key to that one as well. So what I would encourage you to do as far as studying for this exam is concerned, focus on the calculations, focus on the concepts, make sure that you know how to do those things. Don't worry about the procedure, don't worry about the observations, worry about kind of the big picture, you know, very similar to what the quizzes kind of were for those labs. And if you go into the quizzes, if you took the quiz, they should still be available. You should be able to see what you wrote, what the questions were, and everything else. You just can't take them again, but they should still be there. And if they're not, please let me know. So that about wraps this up. Only other announcement I really have is I'm looking into, because it has been requested, I'm looking into doing a study session of sorts for the written final, which is on the last Thursday. And I will make some announcements in class about where and when that will be and what that might look like. So stay tuned. That should be coming at some point. But as far as this video is concerned, that's it for now. So have a good day, and I will see you in lab.